Welcome to Lecture 14. This is on the topic of sensing, policy, governance and standards in sensing. This lecture is part of the subject Future Farming Technologies, which is a component of the Bachelor of Agriculture and Technology, a degree that is offered at both North Melbourne Institute of TAFE and Melbourne Polytechnic. Please visit our website at www.nmit.edu.au for further information on this course and the other courses that we offer. My name is Dr. Nikki Cooley. In this role, we are going to discuss the elements of governance in sensing. We're going to look at risk management and safety. We will then explore the role of politics in sensing, and finally we will touch on sensing and data collection standards. This lecture contributes information across three student learning objectives. Describe and explain the interrelationships between technology, performance, sustainability and production efficiency in agricultural industries. Student learning objective number 2, where we will look specifically at sensing technologies. And student learning objective number 5, where we interpret, communicate and present ideas using appropriate terminology for that technology. So we're going to start with a snapshot on governance, risk management and compliance, or GRC in sensing. GRC in sensing is the integration of governance, risk management and compliance. Policies are formed and influenced by both education, research, applications and operations. Policies are also informed by development initiatives. These policies are often connected with governance and vice versa. In order to understand why we need policy and governance, it might be worth examining an example. I'm going to start with that of the geospatial or GRC. This is an area of science that involves surveyors, engineers, programmers and GIS, as well as other professional bodies. They all have policies and procedures which enable them to operate and maintain responsibilities amongst their various relationships. This is a large area and details tend to be specific to a certain technology and within the sensing community. Businesses often use policy, research and development as well. We have all known cases where policy has changed, often depending upon new leadership or organisational direction. But policy change may also be due to new information and awareness. It is on this point where governance begins. In geospace, governance is dependent on the expectations from the information and acquiring information and data pertaining to those expectations. You can refer to the lecture on GIS and GPS in order to familiarise yourself with this technology if you've indeed forgotten the concepts. Geospatial governance has come from such applications as understanding clean water, monitoring noise, identifying crime, low and high areas, and for issues of safety and security. Geospatial technologies and applications provide the tools and knowledge for gathering information about these factors and thousands of other factors. There are factors that are collected and considered in agriculture. As you may remember, geotechnologies enable us to locate, measure, monitor and model all of these factors. Therefore, you could say they support governance. They provide many of the primary sources of information we need to govern the way we live. To ensure function of this type of sensing, you require convergence or fusion of information and knowledge. Standards in this industry are set to ensure data is correctly used and interpreted. Consequently, we can see governance as being closely related to processing. Where there is governance, you may find legislation. Legislation is where policy is set. This is often in the areas of health and environmental fields. Laws and policies have resulted that include monitoring, implementation, and examination of results. An example of such a policy is the Common Agricultural Policy, or CAP for short. This exists in Europe and is an example of where producers are paid upon depending upon production outcomes. We learned about GPS and how satellites play a role in this. Satellite imagery analysis of the land base is used to determine areas that are being monitored and used to calculate payments in some areas. Geospatial technology can be developed to set this policy. An example of this would be the setting of insurance rates upon flooding potential. In this case, digital elevation maps could be developed to assess flood risk maps, and then insurance rates could be set pending the result of these maps. I want to talk about standard adoptions and innovations in the US. The federal government asserts much influence in the promotion and adoption of industry standards and practices. The investments of large government agencies serve to provide a catalyst for change and to spur widespread adoption of standards and technologies. The approach of the National Geospatial Intelligence Agency, or NGA for short, has been a great influencer of geospatial standard adoption, particularly in the last 7 years. NGA has exerted strong influence through its support of the Open Geospatial Consortium and its establishment of the National Centre for Geospace Intelligence Standards. Australia's equivalent to this is the Defence Imagery and Geospatial Organisation. You can see the link for their website. Our governance is directed by the Office of Spatial Policy, or OSP. It is a central policy unit and it is responsible for facilitating and coordinating spatial data management across Australian government agencies. The URL link is shown on the screen. Now I want to touch on sensing, communications and its governance. ACMA is responsible for the governance of communication in sensing. It is a widely adopted sensing and monitoring technology in its production, processing, distribution and sales processes. Sensor networks play an important role in minimizing the risk of hazardous or poor quality food products being sold for human consumption. Sensors can be used to track, trace and monitor products by employing transducers that measure intermediate environmental aspects such as the light, heat, moisture, location and time. These are all important components in the quality management of perishable products. The following two are examples of different industries that are using different policies and different governance. The Australian viticulture industry has invested heavily in sensing and monitoring. It does this for a number of reasons, but mostly to increase productivity and quality. We have discussed in other lectures input or monitoring of input resources such as water that can enable increases in productivity. One of these such examples was sensing evaporative demand. In order to this, you would measure wind speed, temperature, light, humidity. All of these parameters, in order to ensure that the information that you are getting from them is correct, should ideally adhere to the FAO standards of monitoring. These are a suite of standards developed in the US. In research, it is certainly accepted that FAO policy should be followed. Soil moisture also has a suite of policies associated with it. The livestock produce is another industry that requires monitoring from the primary producer through to the dinner table. We've touched on the National Livestock Identification System, which is the requirement and also uses sensing extensively. The NLIS allows individual animals to be identified and tracked, from the property of birth to slaughter. There are important reasons for biosecurity, meat safety, and market access, and this information all adheres to these requirements. Here is an overall flowchart of NLIS wireless sensor network applications. At each of these points, recommended procedures and policies exist to ensure the proper flow of data. Everything is recorded in the NLIS database. Smart Trace System is a commercial example of an innovation that enables NLIS. You can find information on this system at the ACMA website. Basically, it is a system that uses RFID small sensor tag technology to monitor perishable foods throughout the supply chain. It is regulated by a suite of policies that enable exact data. The ACMA is interested in the ways emerging smart technologies affect service delivery to customers. There are regulatory implications for ACMA findings into this area. The ACMA views sensing and monitoring technologies as smart technologies that will have potentially significant impact on how information-based services are developed and then used by consumers. If we think for a moment about devices, there are many devices out there, and this has a certain suite of implications. Let us start with the Internet of Things. This introduces a raft of regulatory implications. This technology presents challenging issues and an interesting operational environment. The device number, for example, is an issue. The connection processes and management of the data through these devices is also potentially an issue. The devices need to be interpretable with a variety of networks, and they need to be able to autonomously join and leave the networks as they are required. Trusted relationship between consumers and the industry will be needed and this will have to be extended to the devices. There is a predicted population of devices in the order of tens of billions, which require new technology to deliver reliable, scalable, and accessible services. The IPv4 addressing scheme has only 2 to the 32 or 4.3 billion addresses and is nearly exhausted. A shocking thought. The relevance of this is that a device number has impacts on security. If we look at the Internet Protocol Security, or IPsec, it is an integration and design of the IPv6 architecture, and it is mandated as a fundamental interoperability requirement. The IPv6 also has an inherent network security capacity. It provides for standardized end-to-end encryption and/or authentication at the network layer and may be developed to protect any upper layer application. When we consider data communication, we also need to consider wireless and cloud environments. Embedded in mobile sensors, there are associated services that depend on wireless networks to offload their data to back-end services in the cloud. The cloud provides unprecedented scalability and resources for the collection and analysis of large-scale sensor data, and is being used in agricultural applications as we speak. Utility companies and other providers have critical services that need to also consider the reliability of their services, while some services such as email, telemetry, data, and customer support are now being provided by the cloud environments. Sensor monitoring for health and critical infrastructure will require robust operation and redundancy capacities to avoid life-endangering outages. Identity management is also something that needs to be considered. There are possible issues in the future for identification management. The responsibility for such devices is in the area of interest for the ACMA. and it aims to ensure the community continues to benefit from the spectrum assets and is protected from unsolicited communications. This presents an environment with increased cybersecurity risks to sensitive information and infrastructure assets, and certainly could be an issue in agriculture in future years. An example of such a cybersecurity risk is that of the SOOCnet worm, which is a malicious software that targets industry software to subvert programmable logic controllers that interface with sensors and actuators. This may sound like a load of nonsense to you, but putting it in layman's terms, you may have a warehouse that keeps meat cool. This warehouse is controlled by sensors and actuating programs. If somebody was to tap into your communication protocols and say, turn off the cooling components, all your meat could be ruined. Worse than this, if they were to turn the meat off for a short period and then they were to get rid of the data showing that the meat had been warmed for a small period, then cooled it again, that meat considered as healthy could be then put on the supermarket shelves and sold to people and have high risks of food poisoning because it was warm for a short period. These are the sorts of issues that we may need to address in agriculture and food safety in the future. Certainty in data ownership, security and rights of the use are important foundations for a functioning digital economy. Data can be collected from many sources such as a private sensor network, crowd sensing from smartphones, traffic matrices from network operators, and service application usage by users. The issue of ownership of data is a difficult one and an evolving one. Ownership of data, data privacy and choice are all relevant consumer issues. Consumers are also becoming increasingly aware of the invasions of privacy through direct harvesting of information by applications and service providers. Certainly there is evidence of this on such interfaces or softwares as Facebook. The ACMA have put together a suite of solutions for some of these problems. Electricity smart meters, electronic smart card ticketing and tool tags are examples of sensing and monitoring applications that have met consumer resistance. The liability for actions of autonomous systems is also a concern when multiple entities are involved in the provision of services to customers. In this area, a law is only as good as it can be policed, and there are significant challenges of the policing for this technology. So in summary, we have considered some aspects of government's risk management and compliance in sensing. We have looked at some detailed examples of spatial policy. We have looked in detail at the organisation ACMA, its concerns, policies, issues, and its governance. We have an example of such system. Research the governance, the risk, the compliance requirements for all of your industry and your sensor and communication technologies and your data storage devices. Before you take on any sensing system, you need to understand the risks and the implications of such legalities and policies. Most of this will be enterprise specific. Therefore, you will only need to investigate the area that you intend to sense in, e.g. plant sensing or animal sensing. This brings us to the end of this lecture.